Greetings! We have always wanted to discover our origins. From ancient times, we gazed upon the world around us, which we call Earth, and what we saw was an immense flat world. No matter where we looked, we couldn't perceive its curvature, so the most logical conclusion was that the world was flat. Then we turned our eyes to the sky and marveled at the stars and the moon. For a long time, we believed that our world was actually flat and vast, never-ending, with ships unable to cross it. Although it was suspected that there might be a boundary, putting limits on everything is a common trait in our species. Moreover, this flat world floated in an immense sea of stars. Only after extensive studies and experimentation did we discover that we live on a planet with a spherical shape, though not perfect. Eratosthenes calculated the Earth's circumference 2,200 years ago, and during the Middle Ages, this concept was suspected. We only became completely convinced of its roundness when Elcano and Magallanes circumnavigated the globe. This indicates that we, as tiny beings, are deceived by our senses, as everything is so vast that we cannot perceive its true shape. Now, we are uncovering our place in the universe, and we find ourselves in a situation similar to that of the Middle Ages in terms of astronomy. We are beginning to suspect that our universe has curvature, although the official theory is that it's flat. But let's break it down. As I've mentioned, our small size and the vastness around us prevent us from deducing the actual size of things. Only through numerous calculations and experimentation do we know that we live on a planet that is far from being an immense world. We are certain that we live on a planet that revolves around a star more than 100 times the diameter of Earth. However, there are other planets and stars in the universe that are much larger, and for a long time, we also believed that our galaxy was the universe. Yet, we later deduced that we live on a great island of stars, a spiral galaxy, and we move within a cosmic ocean containing billions of other galaxies, some even larger than ours. Unable to travel to other places due to the vast distances, we have not stopped in our effort to scrutinize the universe and reach its limits. We only see a small fraction of what exists. However, just as with our planet Earth, we wonder, is the universe finite or infinite? And more importantly for deducing this, what shape does it have? Our current physics is based on a flat universe, as deduced from our analysis of space probes. When we say the universe is flat, we mean in geometric terms. Just as we discovered that Earth is nearly spherical, astronomers use the same system to deduce the geometry of our universe using mathematical parallel lines. On our planet, if two lines extend from the equator, they will eventually intersect at some point in the North or South Pole, depending on whether they go upward or downward. By studying the light from various distant galaxies, we observed that the lines were always parallel. In a curved universe, photons would be expected to intersect, and that doesn't happen with galaxies, no matter how far away they are. There is no hint of curvature in photons, which means either of two things: the universe is so immensely large, perhaps more than we think, and we cannot perceive the curvature, much like our ancestors with Earth, or we are correct, and we live in a flat universe, which means it's infinite. In such a universe, rays of light emanating from different positions will never cross and will continue to advance eternally. If we were to construct a spacecraft capable of traveling faster than light, even faster than the universe's expansion, in a flat universe, it would keep advancing towards infinity, or perhaps it would reach a point where the laws of physics cease to function. Likewise, the rapid expansion of the universe in its early trillionths of a second raises suspicions of a flat universe. Although the universe is thought to be geometrically flat to infinity, in fact, up to 18 different shapes have been proposed, 3 of which we will discuss below. Our view of the universe is limited because we are microbes within it. However, the intelligence of some humans far surpasses our tiny size. Another form we have considered is the hyperbolic universe, which is like a saddle. It would be an open universe, and its shape could be both finite and infinite. It would be slightly curved at the ends and could fold upon itself. If this is the case, it would be finite. Light photons would be parallel but gradually separate. Another astonishing proposed shape is the torus donut shape. Here's the idea: a universe shaped like a torus would need to be folded upon itself and would be finite. If you take a square and fold it, you end up with a cylinder, and if you fold it again upon itself, you have a torus-shaped universe. In such a universe, if you were to travel away from Earth at maximum speed, there would come a point where you would return to Earth from the opposite end. In this type of universe, light rays would be parallel, although they would experience slight curvature. If the donut universe hypothesis were correct, some of the distant galaxies we currently observe could be the Milky Way itself. This suggests that we might be subject to a time mirror effect, seeing ourselves, and we would never actually reach each other. More shapes for the universe have been proposed, and we are getting closer to solving this enigma. Now, a team of researchers from the Universities of Manchester in the United Kingdom, La Sapienza in Italy, and Johns Hopkins in the United States have shed more light on this subject and have deduced that the universe could be curved, meaning it's like an enormous balloon that's continuously inflating rather than being flat, as was previously believed. If these researchers are correct, the universe would be spherical and closed. This implies it's finite. Parallel lines of light would converge at some point, so the universe could be much larger than we previously thought. This discovery was made because scientists observed an anomaly in the cosmic microwave background, which is the echo of the Big Bang that permeates the entire universe. This background provides many clues about its nature and behavior. The data comes from the 2018 Planck experiment by the European Space Agency, which maps the cosmic microwave background with unprecedented detail. Now, scientists have analyzed this data and found more gravitational lenses than expected in the data sent by the probe. Gravity seems to be bending the microwaves even more than physical theories suggest, reigniting the debate about a curved universe. In a curved universe, we could travel in a straight line until reaching a point where we'd return to the starting point, much like on our planet. But unfortunately, we don't yet have an interstellar Sebastian Elcano or Magellan who can circumnavigate the universe and verify this. And I'm afraid we're far from such an achievement. In a closed, spherical universe, the expansion wouldn't be infinite and would halt at some point. The accelerated expansion of the universe increasingly complicates the discovery of its curvature, as the universal sphere containing all of our spacetime expands further. If the universe is indeed spherical, this presents a serious problem in our understanding of physics, and everything might need to be reconsidered from scratch, even the primordial universe. So the question is, do we need to change all the laws of physics? This is what many astronomers fear with this new discovery. Adapting all of the physics we know to this new reality would be apocalyptic in the scientific world. Although the results aren't entirely conclusive, they offer some hope. Many scientists remain skeptical, and more data is needed to confirm these findings. What is certain is that we might be on the brink of a new physics. And the nature of our universe and all we know might be an illusion. And not only that, but the fate of the universe might be different from what we believed. In a flat universe, it's believed that if the average density of the universe is exactly equal to the critical density, it will expand eternally. Dark energy would gradually diminish due to the gravity effect in less space, but eventually, it would increase due to space expansion, leading to a thermal death due to a lack of material for forming new stars, as everything trends toward disorder and expansion. If it's true that we live in a closed universe, its critical density would be higher, and initially, dark energy would act as a repulsive force, expanding space and matter in all directions. However, there would come a point where gravity would eventually halt the universe's expansion. And in the future, it would stop expanding, collapsing upon itself in a big crunch, creating another singularity and resetting everything, much like a singularity in spacetime. Perhaps we live in an infinite loop of big bangs and big crunches, or perhaps there's just a universe with unique characteristics where we can live to tell the tale. These new findings pose so many challenges for physics that many don't even want to entertain the idea of a spherical universe, even though we know that reality can be different and doesn't necessarily have to align with our calculations. New data will either confirm this hypothesis or lead us to reconfigure our entire universal cosmic model. Our perception of the universe has significantly evolved over time, and many more studies will be required to fully understand it. In a few centuries, the Big Bang Theory or the flat universe concept might be as obsolete as geocentrism and the flat Earth are today. Or we might be right. This is how science works, building on data, experimentation, and self-correction over time. If you enjoyed this video, please like and subscribe, share it on social media, and leave your comments.